Welcome KIEI-950 students. Here is a video tutorial on Azure to refresh all of your memories. So, first thing, you have to load your data in. I'm going to assume that we already have our data loaded in, but if you don't, just go to New, Dataset, from Local File to upload the CSV from Canvas. Once you've done that, we need to create our experiment, and all we need is a blank experiment. So first thing we always need is our data. Just drag and drop it. You can right click and visualize. So for this assignment, we have over 11,000 individuals, and we have 1,136 features going all the way across. These are all Facebook page likes. And at the start, we have everyone's demographics. So, because there's so many features, you may want to limit them. You may not want to use all of them. And so we can do that by going to Data Input and Output. Nope. Data Transformation. We want to manipulate our data, and we want to select our columns and data set. So our input is a data set here, output's a data set, we hook them up. Right after hooking up, you're going to get that red exclamation mark. The red exclamation mark means that you need to tell it what columns you want to keep. So in the detail pane, we can launch our column selector. There are a ton of columns here. So if you want to have a lot of columns, let's say you wanted to have all of the Facebook page likes for each user. It's actually easier to do that with a rule. You could start with all columns and then just exclude some column names. So I could exclude gender, age, political, openness, so on and so forth. And I could click OK and it would exclude that. Now, that's going to leave over 1,100 features, which is going to take a long time to run when we're fitting our model and when we're calculating feature importance. So for this video, I do not want to do that. For the purpose of this video, I want not many features at all. So I'm just going to go to by name. Right now, I have all columns. I could just Control A if you're on a Windows, Command A on a Mac, and move everything back to available. This is whatever is going to be in the data set after I run it. So I need our label. And I'm just going to use someone's political affiliation and their personality. I'm going to click OK. So we could run this. After the data set gets loaded, it shouldn't take that long. There we go. And you can make sure that it worked by right-clicking on Select Columns, going to Results Dataset, and visualizing. So now you can see we only have our label and 6 features, but we still have all users. Okay, so when we are training a model, we do not want to use all of our data. So data transformation, sample and split data. We hook our data set into split data. For the purpose of this video, just to show you how everything gets put together, I'm going to reduce this to only 1% going to training, and then the other 99% of users are going to be going to testing. That's going to help everything run very quickly. Now we need to add in our machine learning bits. So we can initialize our model. This is classification because national parks is 0 or 1. And I'm going to use the decision forest, which we know pretty well from class. So again, purpose of this video, I'm going to cut my trees down and I'm going to cut my depth down. So now I have an untrained model and a training data set. Well, I need to train my model, still in the machine learning submenu. In goes my untrained model. In goes my data. I've got my red exclamation mark because it doesn't know what it's trying to learn to predict. So launch the column selector. Typically easier to do by name, but I haven't actually run it through split data, so it doesn't know what data set it's going to see. So I don't have by name. I can do by rule though without running things. So I can just type in national parks. It's going to help me there and click OK. So once I have a trained model, I want to see how well it makes predictions. For it to make predictions, it has to score. So score takes in our trained model, and it takes in the data set that we want it to make predictions for. Connect my trained model, and I connect my testing data set. Now, once I have a set of predictions, I want to see how well my model did, so I want to evaluate it, and I want to evaluate the model. That takes in the scored data set, which is what scored model outputs. Now, a new part was I want you to understand what features are driving the prediction. So that's feature selection, and I'm having to use permutation feature importance, which randomizes data values in the training data set with the trained model to see what causes the biggest impact on its performance. Permutation feature importance takes in a trained model and a test data set. So we hook up our trained model, and then importantly, we hook up our training data. We just want to see what's driving how the model was trained. This is your entire workflow. We can run everything. There we go. So when we don't have a lot of features, when we don't have a lot of data, and we have a very small model, it runs pretty quickly. So we can go to evaluation and see how well we're doing. As you would expect, not well, right? Given everything that's going on. We don't even have a single true positive. So the first part of this assignment is really optimizing evaluate model. The second part of this assignment, once you've optimized your model, is to understand what's driving those predictions. And that's permutation feature importance. And so if our model was working at all, these would have scores. And the scores would tell you relatively how important one is in comparison to the other. This is a data set. You can't actually get a data set out of Microsoft Azure. So if you wanted to take your feature importances and put them into Excel, you actually need to do a format conversion. You could convert to CSV. So a data set goes in to convert CSV. I'm just going to run selected here real quick. And out comes a CSV. So now when I right click, go to results dataset, I can download it. And that's going to download a CSV. So you could open that up in Microsoft Excel. Now, if you've already played around and you understand the basics of how to optimize this decision forest, well, you may want the machine to kind of tune itself for you. So you could go from a single parameter to a parameter range, and now it'll test multiples. So not just 2 trees, but it'll try 1 tree, 8 trees, 32 trees. So I'll do 2, 3, 4. Again, just for speed, 3, 4, 5. And these won't have that much of an impact with these settings here. But now I could run my model. It's going to take a little bit longer because it's trying out all those variants. So now we can visualize, and hey, we did a little bit better. There we go. We actually made some real predictions. And because we made real predictions, we're going to get real feature importances. Now, bigger is better, and you can relatively evaluate these. So, openness is about 3 times as important as neuroticism in terms of making a prediction, right? This gives you your ranking. So that's the tutorial. If you have any questions, remember there's office hours next week. And if those office hour times don't work for you, email for an appointment. Hope you have a great Sunday and rest of your week.